Okay, another review on standard 7. This is getting boring, I know it is, but now's not the time to be branching out, trying to stress people out, okay, with a bunch of new stuff, okay. You guys probably aren't in the mood for that right now. Okay, now, your job's to find where the lines intersect. I need to use this crappy Sharpie because I don't have any other thing to write with. Okay, just put it right there because you got another different problem. These are both in slope in, okay? You got y equals mxb, y equals 1 mxb, okay? So slope in, both of them are in slope intercept form, okay? So slope y int and slope y int. Okay, so the first line has a slope of 2. It's 2 over 1, and the y-intercept's -1, so 0, -1. Okay, so we go down, make a little dot there, and then we go up 2, right 1, up 2, right 1, up 2, right 1. You can do it a bunch of different times, but that's where the line's going to go through, okay? And it'll show you all the solutions to the equation for x and y, any point on that line. Okay, now this next one, 1 over 1 would be your slope, and then -4 is your y-intercept, so 0, -4. So you're going to go down 4 units, 1, 2, 3, 4. Then you go up 1, right 1, up 1, right 1. Okay, now they are going to cross. They're not parallel. Okay, crossing point's not quite as slick. I'll be the first to admit. So it looks to me like they cross somewhere. Now yours might look a little bit different, and that's fine. You just got to be in the vicinity. Now if you're crossing points like up here, that's wrong. It's got to be somewhere in the vicinity. Okay, so I go left. I go left 1, 2, 3. So -3 is the x value at the coordinate that intersects. So 1, 2, 3. It looks like me. And then y, you're down 1, 2, 3, 4, 5, 6, 7. So -7 is your y. Okay, the next one. Finding the point of intersection. Now, this one, here's the equals. The x and the y are being added together, so they are both in standard this time. Okay, so standard. Okay, so we set up these two tables for each equation, okay, one for each. So x, 0, 0, 0, 0. Okay, we jot the equation down twice for this one. So 2x plus y equals -5. If that's driving you nuts not having a number there, just put a 1. And 2x plus 1y equals -5. Okay, if x is 0, we can delete the 2x, divide by 1. It's going to be -5. It's really why it's not all that necessary to put anything there. And then if y is 0, we're going to delete 1y and then divide each side of the equation by 2. And that's actually a decimal, but that's okay. Negative, but it's a nice decimal where I can find it. I mean, it's -2.5. Okay, so on the y-axis, you're at 1, 2, 3, 4, 5. Okay, and then -2.50, you go left 1, 2, and then halfway. And then you take your ruler. You really need rulers on this because you want to find the intersection point. You want it to be as accurate as it possibly can be. Now this one's a little bit tough because it's got a decimal as the answer, okay, as one of the intercepts. But I just do the best I can, okay? Okay, now in the other equation, you got -x, which will be 1x, plus 3y equals 6, and then -1x plus 3y equals 6. So if x is 0, you can delete -1x from the equation, and then 3 times y is 6. So what number would y be? Well, 2. Here, if y is 0, 3 times that deletes, and then -1 times x is 6. Okay? X is -6. Okay? Because -1 times -6 is +6. Okay, so now I go up 2, and then negative 6, 0. 1, 2, 3, 4, 5, 6. Okay, they are going to cross. I just do the best I can to label the point where they cross. So it looks to me like on my line I'm at negative 1, negative 2, negative 3. So we're at negative 3 for our x. We're up 1 for the y. Okay, now it's doing it without the graph. Now remember, there's 2 ways we can solve without a graph. There is the substitution method, and there's the elimination method. You got to know when to use which one, when which one's the best to use. Now, if you can find a variable by itself, that's substitution. So in this system, and in both of these systems, I'm finding the point where the x and the y, what point would be on both lines. Okay, we have a letter by itself. That would be the substitution method. So I'm going to box up my x and circle the other side. This is known as my base equation, with x being the base variable. Now I write the off-base equation. So I've got 2x plus 5y equals 7. Okay, now make sure your x and y both have coefficients, which they do. The x has a 2, the y has a coefficient 5. And if I have a variable without a coefficient, I just use 1 as the coefficient. And make sure you don't have any minus signs. They're going to cause problems. Make them plus, negative, but I don't have any. So x is the base variable. That's the one that needs to be removed. So I go 2 parentheses plus 5y equals 7. You got to remember to add 5y after your parentheses and not just put equals 7. You cannot forget about this term here. Okay, so negative 4y plus 2 is what I insert, and now I solve the equation for y. Okay, so it gives me negative 8y plus 4 plus 5y equals 7. Okay, here's my equals, and the y's are on the same side, so don't use your addition or subtraction property of equality. You just need to add these. That's negative 3y plus your constant of 4 equals 7. Okay, then I just minus 4. And negative 3 times y equals 3. Then divide by negative 3. And divide 3 by negative 3, and that's negative 1. But remember, that's the y variable. Substitution, you really got to pay attention to what variable. So to solve for the x, let's go into the base equation, because x equals negative 4 times y plus 2. But now I don't need the y there, because I know the y is negative 1. Okay. So I take negative 4 times negative 1 plus 2. The answer is 6, but here's how you'd calculate that if you had to. Okay, boom. So 6 negative 1 is the point of intersection. Okay, now my next one, I've got 3x plus y equals negative 1, and then 2x plus 3y equals 18. Now in this one right here, I don't have that variable isolated, okay? There's a y here, but there's a plus operator with it, so this would be an elimination method. So first I look at the equation. I see if either the x's or the y's can add to 0 so they can be deleted from the system. 3 plus 2 is 5. 1 plus 3 is 4. So not even close. So we have to use the boom, boom, boom. Boom, boom, boom. So I have 2, 2, 2, 2, and then 3, 3, 3. Okay, 3x times 2 is 6x. 1y times 2 is 2y, and then negative 1 times 2 is negative 2. And then in the bottom, you're going to have 6x plus 9y equals 18 times 3 is 54. Now, remember, we're going to add these again, but 6 and 6 is not 0, so we need to use the multiplying of negative 1 on the bottom, meaning I just changed the sign. So this 6 now goes negative. this 9 becomes a negative, and this 54 becomes a negative. Now, if something's negative, then it goes positive, but they were all positives, so they all go negatives. So I add 6 and negative 6, add to 0. Okay, if you put 11y down, that's wrong because now 2 is negative. If you have a number line and you're adding negative 9 to 2, you're going that way to take you to a negative 7, negative 7y. Okay, negative 2 plus negative 54. Okay, it's going to be negative 56. Then I just simply divide both sides by negative 7, and y is going to equal 8. Okay, so 8 is the solution for y. Now to find your x, you got to use an equation somewhere. I would go with the top. Okay, so we have 3x plus 1y equals negative 1. But I already have my answer for y. I know that y is equal to 8, so I can multiply positive 1 by 8, which is 8. So I got 3 times x plus 8 equals negative 1. And I subtract the 8. So 3x equals negative 9 before dividing by 3. And that's negative 3. Okay, so negative 3, 8 is the point of intersection. Okay, now story problems. I actually got the answers set up for you today. Okay, a group of friends take a tubing trip. They rent 26 total tubes for $360. However, they rent both small and large tubes. Small tubes cost $7.50 to rent, while large tubes cost $15 to rent. How many of each type of tube do they rent? So there's 3 units, okay? Now, if some of you got your own way of solving this, that's fine. It better be accurate. So you got small, large, and then together. And then you have how many, meaning how many units per dollars per, and then total. Money total. Okay, so the total money together we have $360. So forget about that. Now give me a non-money number. 26 is the non-money number, but that's not small or large. That's your total tubes. Well, then for separate, you have to use different variables, x and y. Okay, so this reeks of a system here. Delete that. Okay, our money amount. So the smalls, what's the money amount for smalls? 7.50 and then 15. Okay, so x multiplied by 7.50 is just 7.50x. Y multiplied by 15 is 15y. Okay, you're going to need a system here because there's 2 different variables in the table. So I make my table. Okay, so my system consists of 2 equations. X plus y equals 26. And then 7.50 times x plus 15y equals 360. All right, we need to use elimination. Okay, so 1, 1. These are not even going to come close to adding to 0, so we need to use the multiplication property of equality. So you got 750, so times 750. Times 7.50 times 7.50. The bottom can just be multiplied by 1. Okay, so 1x times 7.50 is 7.50x. 1y times 750 750y. Then 26 times 750 is going to be 195. Okay, 750x, the bottom just stays the same because it's the identity property of multiplication. You're just multiplying it by 1. Okay, now try adding them, but these are both positive. There's no way they add to 0 if they're both positive. So just go negative. 15 is negative. 360 is negative. So adding these will now add them to 0. And I take 7.50 plus negative 15. It ain't just 15. So it's negative 7.5y. And then 195 plus negative 360 is negative 165. Now divide. Okay, so I divide negative 165, divide by negative 7.5, and that's 22. So y is equal to 22. So here's my y variable. That's under large, so there's 22 large. If you know the smalls right now, you can write it in. If you don't, use one equation. 1x plus 1y equals 26. Now I already have the answer for y, okay? So delete the y and put 22 in its place, okay? 1 times 22 is 22, so you got 1x plus 22 equals 26. Subtract 22, and that's 4. You don't need to divide by 1. It's be the same thing. So 4 and 22. Okay, now this one's a little annoying because you don't have the money. Okay, here's your units. You got the plays by Team A, the plays by Team B, and then the yards. Yards just kind of takes the place of where money would usually go. Okay. Team A runs twice as many plays in a football game as Team B. Team A averages 8.5 yards per play, while Team B only averages 2.5 yards per play. This game must have been a crap kicking net. There are 624 yards of total offense gained by the two teams in this game. Find the number of plays ran by each team. Okay, so you got together, and you got plays by Team A, so I'm going to put plays A and plays B. Okay, I wrote those up there so it would be a little less confusing. Then you have how many, and then per and total. But instead of money, because money's not part of the problem, you're going to use yards. Okay, now what's your yards total together? 624 yards of total offense. How many means an amount that has nothing to do with yards. These say yards after them, so we can't use those up here. Probably twice, okay? I mean, twice as many plays. Doesn't really have anything to do with yards. Now, twice, what does twice insinuate? It means it's unknown, but it's multiplied by 2. So multiplying a variable by 2 is 2x, and then the other one's just x. Okay, so Team A ran twice as many plays. Makes sense because they obviously kicked the crap out of the other team. So 2x, x, and I can delete that. Okay, remember, twice of an unknown's 2x, not x2, 2x. Okay, now get your yards. So you got Team A 8.5 and Team B 2.5. Well, you're easily going to be able to do the yards total for Team B. X times 2.5 is 2.5x. And then here, do you have a plus operator? No, you don't. So you don't do a parentheses. You just simply put x down and then times 2 by 8.5. Make sure you put the x down first. Okay, 17x. And you don't need a system. You have a straight line equation. 17x plus 2.5x equals 624. You can just add your x's. That would be 19.5x. Then divide both sides by 19.5. Okay, so 624 divided by 19.5, 32. So x is 32. So here's where the x is isolated. That must be the plays ran by Team B, 32. Okay, and then the plays ran by Team A. Now, Team A ran twice that much. That means 2 times x. Well, you just times it by 2, and that takes you to 64. Okay. Okay, next problem. A A sports equipment store is having a sale on soccer balls. A soccer coach purchases 10 soccer balls and 2 soccer ball bags for $155. Another coach purchases 12 soccer balls and 3 soccer ball bags for $189. Find the cost of a soccer ball and the cost of a soccer ball bag. By the way, I put money signs down here. The copy machine appears that it got it. So if I get decimals, it's not a big deal because I'm finding the cost. Okay, so you got together, and you got balls and bags. Better not put B and B, you get them mixed up. Then how many per, so dollars per, and dollars total. Okay, money total, I have 2 different ones. You have 155 and 189. At this point, you should be thinking, oh yeah, it's one of those where I'm going to have 2 items in every box. Okay, non-money, so 10 balls, 2 bags. Okay, and 12 balls and 3 bags. You need to line them up just like that. Okay, so since I'm able to individually label these, I not have a use for the together box. Okay, now you're basically out of values, so you need, these are unknown, okay? Well, duh, they're your answers. So XX, YY. So it gives me 10X and 12X, and then 2Y and 3Y. So again, we need a system of equations if we're going to solve this. Okay, so I know that 10x plus 2y equals 155, and I also know that 12x plus 3y is equal to 189. Okay, so 12, 12, 12, and then 10, 10, 10, multiplication property of equality. So that gives me 120x plus 24y. And then 155 times 12 is 1,860. And then on the bottom you have 120x plus 30y equals 1,890. Okay, you're going to do the little adding, but 120 plus 120 is not 0, okay? This would have to be negative, so then this is negative and this is negative. Okay, now that deletes the x's from the system. Now I add 24 and negative 30. If you write 54, it's wrong. It's negative 6y. Okay, and here we have a negative 30. And then divide both sides of the equation by negative 6, and y equals 5. So here's my y. So the bags cost $5. Now there is no quick way really to get your other one. Okay, like you could on that small large tubes one, because I really don't have anything I can go off of for together. So I'm going to use the top equation, 10x plus 2y equals 155. Okay, y is 5. It means we'll delete the y and take 2 times 5 is 10. So 10x plus 10 equals 155. Then I minus 10 and divide by 10. So it gives me 10x equal to 145 divided by 10. Now, for 145 divided by 10 is 14.5, but fortunately for us, we're finding a cost amount, so 14.5 actually makes sense, so 1450. Okay. Okay, now, last story problem, then I got some other things I want to show you in this video. Make sure you did them. Okay, an adult pass for a fair costs $2 more than a children's pass. When 378 adult and 214 children's passes were sold, their total revenue is $2,384. Find the cost of each type of pass. Again, these are money amounts. So if I get a decimal, it's no big deal. You're not going to need a system on this. The more than and the twice, you don't need systems. Okay. Okay, so we have the adult, we have the children. And then we have how many per, so dollars per, and total. Okay, so the total money amount's $2,384. Okay. All right, now give me some non-money quantities. So you have 378 adults, you have 214 children, You can add these, it's 592, but that's not really going to do anything. Okay, now cost, $2 more. Now we know twice of an unknown is written as 2x, but 2 more than an unknown is x plus 2. Okay, and then the other unknown's x. So the adults are 2 more. Now since you're using a plus operator, please put that in parentheses, and then your x goes here. So the children's easy. You got 214 times x, that's 214x. Now for the adults, because you have a plus sign, you need to do a distribution. So 378 times x is 378x plus, and then 378 times 2 is 756. Okay, you can write a straight line equation, okay, because you only have one variable to solve for. So 378x plus 756 plus 214x equals 2384. Okay, your x's are on the same side, so add those. 378 plus 214 is 592x, plus our constant of 756 equals 2384. Okay, subtract your 756 from both sides. 1,628, so 592x equals 1,628. Then I divide by 592. And I get 2.75, but that's okay because we're finding dollars amounts. Okay, so here's your single x. That's under your children, or I guess student in this instance. I've kind of screwed the labels up. Okay, and the other one, you know, is just 2 more. So you just add 2 onto it, and that's going to be $4.75. Okay, now you're like, why are we doing more of these? Well, here's why. Okay, this is something I haven't really taught you. Okay, it's not a big deal. It's not something to get freaked out about. But when you use elimination, which you would on this problem, and look at what's going to happen here. This is something you have not seen. So 2x times 1 is 2x, 6y times 1 is 6y, and then 18. In the bottom we have 2x plus 6y equals 18. Okay, now remember our goal is kind of to drop the x's from the system. So I go negative, 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 but a little funny thing happens. We know that deletes. But unfortunately for us, well actually fortunately because the problem's easy, that also deletes. So we have just 0 on this side. Now these also, that's 0 as well. Now 0 is equal to 0. So the answer to this is what's known as infinitely many solutions. So you can't really label that. That's your answer. Now here's what infinitely many solutions means. That means if I were to graph the 2 equations on a line, I don't know how these graph. I'm not going to show it. I'd make a first line. And then I would make a second line, but you see the second line would simply just go over the first line. Well, those lines are always touching, okay? So that's why it's infinitely many solutions, okay? It's pretty much the same line. So I'm going to put same, write down on your paper, same line, okay? They're just written differently. Okay, now, next problem, it's different, okay? So times 6 times 6 times 6. If you're good with least common multiples, you could actually just times this by 2 and leave this one 1. And you'd both have them as 6, but we'll go with what we know. So 18x plus 24y. 24 times 6 is 144. Then on bottom you get 18x plus 24y. I think you see what's going to happen. 24 times 3 is 72 though, so I don't think that's going to go away. Okay, to delete the x's from the system, they have to be opposites. Negative, negative, negative. Now the x's are deleted, but so are the y's. But I don't think that's 0 this time. So you add 144 plus negative 72, and that's 72. 0 doesn't equal 72 though. Okay, so it's not going to be infinitely many solutions. It's going to be no solution. Now I want to show you on a graph what that would look like. Okay, I'd graph my first line, let's say it looks like that, and then I'd graph my second line. Now it wouldn't go over the top, it wouldn't be the same line. That's infinitely many solutions. It would look like this. Well, they're never going to cross. So they don't cross in a point, they're parallel lines. So that's what you write. They're not the same line, instead they're parallel lines. No solution, parallel. Okay, so that really hasn't happened, but that's part of the unit. I really didn't have time to get into that in great detail, so now is my opportunity.